Welcome everybody to the practice, solve, and graph inequalities number 2 assignment. Okay, number 1 says we have to list the first 3 integers that satisfy the inequality y is less than 0. What this means is we need the first 3 whole numbers that are less than 0. So think about it. If you had a number line and you had 0 and 1 here, well, what would you put to the left? So 1, 0, negative 1, negative 2, and negative 3. So that's choice B. The first 3 integers to the left of 0 would be negative 1, negative 2, and negative 3. Okay, again, just keep the number line in mind when you're doing these types of problems. Okay, number 2. List the first 3 integers that satisfy this inequality. This one is g is less than or equal to negative 7. So let's just keep the number line, erase the numbers. Put it here, negative 7. So greater than that, as you're approaching 0, would be negative 6, negative 5. Less than that, as you're getting further away, negative 6, negative 7, negative 8, negative 9, and negative 10. So the first 3 integers here, be careful, they are not negative 8, negative 9, and negative 10, because it says less than or equal to. That's where this comes into play, right here. See, less than or equal to. That means we have to include that number, which is negative 7. So that's the first integer that will help to satisfy this inequality, negative 7. And then, since we already chose one number, now we only need 2 more. So less than negative 7 is negative 8, and less than that is negative 9. So just be careful to include that negative 7 as part of your solution. So choice C is our answer. Okay, number 3, again, we have to list the first 3 integers that satisfy this equation, or sorry, this inequality. This says Q is greater than 3. So again, let's wipe this out real quick. And if we had 3 here, greater than that, 4, 5, and 6, less than that, 2, 1, and 0. So the first 3 numbers that are greater or to the right of the number 3 would be the numbers 4, 5, and 6. So this is choice D. So again, it does help to have a number line. Make sure you put it there if you need it. And now we'll get to number 4. We'll just erase this. Now, this we can slide over, and this we can also slide over. All right, so number 4, we have to solve this inequality. This one says 4x plus 2x is less than 72. So before we do anything, what we should try to do first, well, inequality symbol, let's draw the line. Again, this line separates terms on the left side of our inequality, positive 4x and the positive 2x, from the term on the right, which is positive 72. But notice how on the left side, we have 2 terms, the 4x and the positive 2x, and what do they both have? Well, they both have the letter x. What this means is that those are like terms. We can combine them. To do that, we're literally going to do what it says. It says 4x plus 2x. So 4 plus 2 is 6. So we get 6x. And then we just bring down our less than symbol, bring down our 72. And by combining the like terms, now we only have one term on the left, which is the 6x. Now we want to get x by itself. So to get rid of that 6, we know it's multiplication, 6 times x. And because we're looking at multiplication, we undo it with the opposite operation of division. So divide by the coefficient of 6. Remember, coefficient is just a number in front of the variable that's multiplying it. So do the same to both sides. 6 divided by itself is 1. Goes out. Bring down our variable x. Bring down our less than symbol. And 72 divided by 6 is 12. So x is less than 12. Choice A. Okay, number 5, we have another inequality to solve. This one says w over 2 plus 4 is greater than or equal to 14. So same first step, inequality symbol, draw the line. Next, we want to get w by itself, but there is another term next to it. We're looking at the constant, which is positive 4. The opposite of adding 4 is to subtract 4. So we need to subtract 4 on both sides. We haven't done anything with the w over 2, so let's bring that down for now. 4 minus 4 is 0, so cancel that. Bring down our inequality symbol, greater than or equal to. 14 minus 4 is 10. So now it says w over 2 is greater than or equal to 10. Now what we should do at this point, if you remember how we solved problems with fractions and equations, we're going to do it the same way for an inequality. So when a variable is by itself, in this case w, and you look at it and you say, well, it doesn't have a number in front, like it doesn't say 4w over 2, right? Be careful, because it actually does have a number. When a letter, a variable, is by itself, there's an invisible number 1 in front of it. So let's put it. So it's really 1 over 2 is the fraction, or 1w over 2. Now, again, just like an equation, we want to put the 1 there because now we're looking at it and we see a division problem, since it says 1 over 2, which means 1 divided by 2. And to get rid of a fraction, we should remember we have to multiply because it's the opposite of dividing. Not only that, but we multiply by the reciprocal. Reciprocal means for this fraction, instead of 1 over 2, becomes all the terms now are fractions except the 10. That's a whole number, so let's make that a fraction also by putting it over 1. Again, we put it over 1 just because it does not change the value of the number. 10 divided by 1 is still 10. Okay, now I have all fractions, and again, we've dealt with fractions and equations, so we should remember this. But multiplying a fraction by its reciprocal will get rid of the fraction because it's going to leave us with 1 in the front. Because cross-canceling, 2 divided by 2 is 1. You don't have to put the 1. 1 divided by 1 is 1. Again, you don't have to put the 1. But the whole purpose in doing this is to get w by itself, which it is right now. Now bring down our inequality symbol, greater than or equal to. And now let's multiply our numerators. 10 times 2 over. Multiply denominators. 1 times 1 is 1. And finally simplify. So w is greater than or equal to 20 divided by 1 is just 20. So that is our solution. Choice B. W is greater than or equal to 20. All right, we have a few more to go, so let's go down to number 6. Number 6, we have to solve and graph this inequality. It says 7 is less than S. Now you might look at this and say, well, what do you mean solve? It's done already. The constant is on one side and the variable's on the other side. The inequality symbol's in the middle, so we should just graph this. Well, not that it's not solved already, but if you notice, let me just scroll up. If you look at every answer done so far, or actually the last two numbers, 4 and 5, what do you see? Okay, yes, you see a number, which is a constant. Yes, you see an inequality symbol. Yes, you see a variable, but where's the variable? Is it on the left or the right side? If you're on the left, variable is on the right side. So what we want to do is to put our variable on the left side, just like in number 4, where x is on the left, just like in number 5, when w is on the left. So we're going to just rewrite this inequality statement of 7 on the left side and s on the right. Let's just switch those two places. So s is going to be on the left side and 7 on the right. But we can't just switch it like that, because what did we forget about? Well, in between them, they have an inequality symbol that says less than. So if we switch the place of our variable s and our constant, the number 7, we also have to flip our inequality symbol. So instead of less than, it's now going to say greater than. So this is the inequality statement that we want to graph. So s is greater than 7. Do that. So before 7 or less than 7 is 6. Now we need our circle. We're going to put it on our solution of 7. It's open because it just says greater than. Remember, if it's less than or greater than, you're going to have an open circle. Less than or equal to, and greater than or equal to, they have closed circles. So there's no line, doesn't say or equal to, so it stays open, and it's pointing to the right. So we go shading to the right on our arrow. Again, quick tip to remember that one, which we've discussed now in a couple videos. Put the symbol, put the line. That is going to the left. That means less than. If you have the other symbol that we had just now, this one, actually let me move it over, put the line, is going to the right. This is greater than. All right, so our answer for this one was choice B. Choice B says S is greater than 7. All right, 2 more and we're done. So number 7, number 8, they have word problems. So let's get to number 7. 7 says Naomi eats at most 2,000 calories per day. If she has 534 calories for breakfast and 642 calories for lunch, what is the greatest number of calories she can have for dinner? So remember, with word problems, let's take them apart piece by piece. This says Naomi eats at most. Now what that means is she cannot eat any more than this number. So that's the greatest number it can be. So that symbol is going to be less than or equal to, because again, she cannot go past this number. That's the highest. So she eats at most 2,000 calories. Now it says she has 534 calories for breakfast. So let's put that 534 and, which means add 642 calories for lunch. And it's asking us about the greatest number of calories that she can have for dinner. Well, we don't know. It hasn't told us. So if we don't know in math, again, we represent an unknown number by using a variable, a letter. So I'll just use, well, plus, because this is dinner. I'll just use the letter D for dinner. So there's our inequality. Solve it like how we've been solving it, where your symbol is, you draw the line, separating terms on the left from terms on the right side. And if we're looking, we're going to see there are three terms on the left-hand side, 534, the positive 642, and the positive D. And what we want to do, just like a number, I believe it was 4, yep, number 4, where we have like terms, we can combine them. So let's go down. Number 7, our two like terms are these two, the positive 534 and the positive 642. Those are like terms because they don't have variables, so they're called constants. Remember, constant is a number with no variable. So I'm going to do exactly what I see, what it says. It says 534, and then it says plus 642. That's exactly what I'm going to do. 534 plus 642. That gives us 1,176. Now we haven't touched anything else in the inequality yet, so we're just going to bring those down. So plus D less than or equal to 2,000. Now we just have one more step to go to solve this inequality. We have the variable D, and next to it we have the constant term positive 1,176. Just move this down, get some space. So to get rid of the positive, we have to do the opposite, which is to subtract. So you want to subtract 1,176 on both sides. 1,176 minus itself is 0, so cancel that. Bring down your variable D and your less than or equal to symbol. And 2,000 minus 1,176 should be 824. Let's just double check. 2,000 minus 1176. Yep, 824. So that's our solution. What that means is the greatest number of calories that Naomi can have for dinner without passing the 2,000 total is 824. So 6 inches more than twice his daughter's height. If he is 76 inches tallest that his daughter can be. Okay, so what do we see? We see Mr. Wilson's height is at least 6 inches more. That's a lot. A lot even, and we kind of have. What I'm going to do now is in the problem. So I'm going to say let x equal his daughter's height. So this is for the daughter. And for Mr. Wilson, again, if we reread that first sentence, Mr. Wilson's height is at least 6 inches more than twice his daughter's height. So twice, that means 2. So 2 times x is 2. Twice his daughter's height. So we're going to say let 2x plus 6 equal Mr. Wilson's height. Okay, now we have our let statements written, and now we can start to form our inequality. So how will that look? So we have the daughter. Her height is x plus, now we have Mr. Wilson's height, which is 2x plus 6. And remember, his height is at least. At least means greater than or equal to. And it says that he is 76 inches tall. So think of that as being the total. So that's our inequality that we, as I just did here, to reread word problems more than one time, because by doing so, you'll be able to gather more information that you need. Okay, so here's our inequality, and we have to solve it. So inequality symbol, let's draw the line like we usually do. Now let's look. On the left side, we see not 1, not 2, but we see 3 terms. So anytime there are multiple terms on one side, let me just scroll up for a second, such as in number 4, where we had the 4x and the 2x on the same side, or the last problem we just did, number 7, where we have the 534 and the 642 on the same side. We want to see if we can combine like terms so there are not so many terms on one side. So let's look at number 8. What like terms do we have? Well, out of the x, the positive 2x, and the positive 6, which two can we match together? Well, we can match these two together. Whether we're adding or subtracting. So it says plus 2x. Now be careful. Remember, when a variable is by itself, even though you may not see it, it has an invisible number 1. So x plus 2x is not going to be 2x. It's also not going to be 2x squared, which is 2x to the second power. But you should put the 1 just to remember it's there. So 1x plus 2x will now give us 3x. Another way to kind of figure it out, if you have, let's just draw a picture, sometimes that helps. If you have 1x here, and you have 2 more here, how many do you have all together? Well, if we combine it, let's put it with these, and now we have 1x, 2x, 3x's. Right, so sometimes drawing a picture in math can help us to visualize the problem a little bit better. So that's how we get x plus 2x as being 3x. Okay? All right, now we're just going to bring down the other terms that we haven't used yet. So plus 6 is greater than or equal to 76. And now we just have 2 more steps to go. So if we want to get x by itself, we're going to see that we have the constant term, the plus 6 or positive 6. So do the inverse operation there. Opposite of adding 6 is subtracting 6. Do that to both sides, keep it balanced. Now we haven't used the 3x, that's okay, just bring it down. 6 minus 6 is 0, just cancel that. Let's bring down our inequality symbol. Greater than or equal to. And 76 minus 6 is 70. Last thing we want to do here is to divide. So let's divide 3 on both sides. Way back. 70 divided by 3 is going to give us a repeating decimal, so I definitely did something wrong. 23.3, which is 23 and 1/3. All right, so that's why it helps to kind of look at what we've done and kind of figure out where we went wrong. So let's see, Mr. Wilson's height. Okay, I went a little too much. So what we actually needed to do was, if we're thinking about the daughter's height, we don't actually need to put the daughter's height. We could just start with Mr. Wilson's height. We don't need the x. So 2x plus 6. I'm keeping this here in the video just so you can see that sometimes math teachers, we make mistakes too. So we're just going to keep Mr. Wilson's height, and from that we can figure out the daughter's height. So this will change slightly, not a lot. So now it's just 2x plus 6 is greater than or equal to 76. And these steps pretty much will actually stay the same. Numbers will change a little bit. Still going to subtract 6 on both sides. Now this is going to say, not 3x, it's going to say 2x. And now we have to divide by 2 on both sides. And now 70 divided by 2 is 35. So x is greater than or equal to 35. Right, so that's why we have to just double check our work just in case we make a mistake. All right, so practice, make sure you practice, and I'll catch you on the next